Hi everyone, I'm going to quickly go over this practice test. It's our last test of the year. When you take your test on Thursday, make sure you check the mode on your calculator and make sure degrees is highlighted. Because if you're not in degree mode, a lot of your questions are going to be wrong. So make sure you're in degree mode. Okay, the first part of this practice test, you're going to see we're converting from degrees to radians, radians to degrees. Very simple conversion. If you're given degrees, you just type in the degrees divided by 180, convert back to a fraction, and add the pi symbol. So 940 divided by 180, you can use your calculator. So if it helps you, use a calculator, divide the number of degrees I give you by 180, and then hit math, enter, enter. And then there's your fraction, and then you have to make sure you put the pi. So it's 47 pi over 9 radians. Okay, so number 2, same thing, divide. Doesn't matter if it's negative. You can see the answer for number 2. If I give you radians, you're going to take your radians and multiply by 180 over pi. The pi's will cancel out. And in this case, 3 halves times 180, 270. Okay, super easy points on your test. Okay, the next part of your test, you're just going to be drawing angles from the standard position. So remember, positive degrees, you're going to go counterclockwise. So for 300, I need 90, 90, 90 is 270, and I need 30 more, so my angle is in the 4th quadrant. Okay, if it's a negative, you're going to end up going clockwise. So for negative 660, I'm going to make a complete turnaround to 360, and then I still have 300 degrees to be able to draw yet. So you can see my little work here. Once I do another 90, 90, 90, that still leaves me 30 degrees to go. So my angle is in the 1st quadrant. Okay. If I give you a problem to draw and it's in radians, my suggestion, convert to degrees. And again, if it's a positive 480, I'm going to need to make a complete 360. And then I'm still going to have another 120 degrees to go, which is 90 and then a 30. So this angle ends up being in the 2nd quadrant. Okay. Again, last one, convert to degrees. It's negative 225, so I'm going to go clockwise from the standard position. There's a negative 180, and I still have 45 degrees to go. This is located in the 2nd. In this section, I'm going to be asking for a positive coterminal angle and a negative coterminal angle. So in this case, all I have to do is add a 360. I get 206, and then I can take my original angle, subtract 360, I get a negative value. So again, these are all in the same position. They're all coterminal, all same location. For this guy, to get a positive, I can even subtract 360 because it's beyond 360. So if I subtract 360, I have 5 degrees, which is positive. And if I subtract another 360, I get my negative. Now, if you started right away and added, you have a 725, which is also an acceptable positive. But then you're going to have to subtract 360 twice to be able to get a negative, okay? If I give it in radians, the long way, and again, I'll accept this, is for you to convert to degrees, and then from degrees, find a positive and negative. But final answers, I'm going to need in radians. So again, this is a lot harder to do. My suggestion would be to add a 2 and subtract a 2. So remember, a 360 is really 2 pi radians. So I can take my fraction and add 2. So if I take my original fraction, negative fraction, I add 2, I'm still left with a negative fraction. So there's a negative coterminal in radians. And if I take this fraction, add 2, now I have a positive angle. So my negative angle is negative 25/18 pi, and then I have a positive 11/18 pi. So again, either way, final answers though need to be in radians. Okay, for this last one, I take 5/6 plus 2. Again, use a calculator. 5, 6 plus 2, you get a decimal. Math, enter, 17/6, and then you have your pi. And finally, subtract, and you get this. Okay, for this section, you're going to be finding the remaining trig functions based on a diagram. So in this case, we are originally given this angle, there's theta, the opposite side, and the adjacent we know. Okay, so right away, I know the tangent of this angle is going to be opposite 24 over 7. But to be able to find the other ones, I need to know the hypotenuse. I need to know C. So take your two legs that were given, square them, add them together, take the square root. You're going to see that the hypotenuse is 25. So from here, real easy to find sine, cosine, tangent. So sine is opposite over hypotenuse, 24 over 25. As soon as you know the sine, you might as well flip it, and then you know the cosecant, 25 over 24. Cosine is adjacent over hypotenuse. We have 7 over 25. Flip it for the secant, 25 over 7. Easy point there. And then finally, we already said the tangent is going to be 24 over 7, and therefore the cotangent is the opposite, the reciprocal, which is 7 over 24. Okay? Here, you have to draw a triangle, a right triangle, to help you understand the remaining functions. So I give you the secant. Really, I'm also telling you the cosine right away. 3 over 8. Draw your right triangle and just label one of the acute sides. I label my acute down here as theta, and I know that the cosine is 3, so the adjacent side is 3. The hypotenuse is 8. So it's based on knowing 3 over 8 is the cosine. The missing leg I can find by taking the hypotenuse squared minus the leg squared. You end up getting 55, which you need to take the square root of it. Since it's not a perfect square, just leave it as a square root of 55 to find the remaining trig ratios. So here, sine is going to be square root of 55 over the hypotenuse. Flip it right away, and you're going to get 8 over square root of 55. And finally, tangent is the opposite over adjacent, square root of 55 over 3. Flip it for the cotangent. Easy points. Okay, the next section, and you've done so many of these problems, big ideas, online assignments, where you're going to be finding the missing parts of a right triangle. You should only need to use trig one time. So in this case, I found the missing angle by just simply understanding that all three angles of a right triangle add up to 180. The right angle already takes up 90. 90 minus the given angle. In this case, 90 minus 50 is 40. So easy point finding the missing angle. From here, though, I decided to use angle A, and I knew this side opposite is 15, and I can find the hypotenuse. I can use trig to find the hypotenuse by using the sine of 50. So now here's a harder part to solve, because think about when your variable's on the bottom, think about cross multiplying, and you're going to end up to be able to find C. You're going to have to type in the 15 first. You're going to end up to solve for C. I have to take 15 divided by the sine of 50. So when you do that, making sure your calculator's in degrees, you're going to get 19.6. So C, the hypotenuse, is 19.6. To find the remaining leg, you just need the Pythagorean theorem. So C squared minus, in this case, A squared, I was able to find B by taking the square root. Okay? So again, we've been using the Pythagorean theorem for a long time. This next one, I can find angle A. I'm given two sides. You could use the Pythagorean theorem right away to find side A, but I decided to use trig right away, and I used the cosine of A because right here is my adjacent side. The longest side, the 9, is hypotenuse. To be able to find an angle, that's where you use inverse, second cosine on your calculator. That makes the cosine disappear. You type in second cosine, and you take 8 divided by 9. As long as you're in degree mode, you get 27.3 degrees. Then it's real easy to find the other angle, 90 minus the angle we just found. And again, at least round to the tenths. And then finally, to be able to find the missing side. You don't need trig. You can use the Pythagorean theorem. 9 squared minus 8 squared is 17. Answer square root of 17, which is a decimal, is 4.1. Okay, the last part is going to be some application problems. Draw this situation. You're going to use a right triangle. Here we're told that the ramp is 20 feet. The height of it is 3.5 feet off the ground. So I'm visualizing a ramp, and we're told to find this angle of elevation between the ground and the ramp. So we know the opposite side was given, and we know the hypotenuse. So that's the sine. So again, to find an angle, that's when you take second and then your trig function. In this case, second sine, type in 3.5 divided by 20, and it's going to tell you about 10.1 degrees. Okay, the last word problem here, we're told that we're 750 meters away from the launch of the shuttle, the launch pad, and we're told that the angle that we're shooting with the camera is a 58-degree angle to the top of where the shuttle is going to be located. And we want to know the altitude, how far off the ground the shuttle is. I drew a horrible shuttle here, but nonetheless, I have the information to be able to find the height, this length. So I use tan because I'm trying to find the opposite side given the adjacent. So the tan of this 58-degree angle is equal to the opposite, which we don't know, we'll be able to solve for, over the adjacent side, which is 750. Here, to solve for x, all I need to do is multiply both sides by 750. I type in the tan of 58 degrees times 750, and it's about 1,200.3 meters. So 1,200.3 meters is your answer. Last test of the year. Please look over your notes, guys. Every section on this test, we have plenty of notes on. We have plenty of additional practice worksheets that you can look at. Guys, refer to Schoology, go through, and look through all the notes. Anything that you're missing in the notes, make sure you look at. Make sure you can do on your own, and then just compare it to this practice test. And I promise you, if you can do this practice test, you'll do very well on our last test of the year. So best of luck. After we take this test, we'll get ready for our final. I realize my voice is horrible, so I apologize for my voice. It's been like this all year long. So take care. Thank you for watching. Probably we'll get about 5 people that will watch this.